Hello everyone, welcome back to our channel. Today we are going to discuss about velocity time graph. In previous class you know that what is the displacement and time graph, and you know that slope of the graph is giving the velocity. But here we are drawing that graph between the time and velocity. Time we are taking on x-axis and velocity we are taking on y-axis. You know that velocity equals to rate of change of displacement. When we are doing the simplification, and you can say that integration of velocity into dt, it is nothing but area of that graph. It gives the displacement. Here I have drawn one graph here. Time we are taking on x-axis and velocity we are taking on y-axis. So area belongs to integration of this system. It is giving the area. Suppose we should consider A. So displacement equals to area of VT graph. Area of VT graph. It is giving the displacement. Suppose you can go through the one more graph. Time here, and this is the velocity. This is the area. This is above the time axis. We can take plus A1, and below that also this one is there. Here this area is giving that minus A2 we are taking. Here how to find out the displacement? In this case, displacement equals to A1 minus A2. Then how to find out the distance? Here distance is sum of the positive and negative areas, A1 plus A2. So velocity time graph gives the displacement, distance, and slope of the velocity time graph is giving the average acceleration. And velocity at particular acceleration at particular instant is called the instantaneous acceleration. Tangent of that velocity time graph gives the instantaneous acceleration. Instantaneous acceleration. Then look here. We are going through the some graph. This is the time and this is the velocity. If the graph is like this, straight line, means it is the initial velocity. Here velocity is constant, and we can velocity is changing with respect to time. We can show this v equals to u plus at. Here suppose you are taking slope of the graph alpha. Here alpha is less than 0, so a is positive. A is positive. Like that, one more graph. Look here. This is the time and this is the velocity. Here the slope of the graph is alpha is greater than 90 degrees, and we can show here a is the negative. A is the negative. So based on the slope of the graph we can say about the acceleration. And one more graph, look here. This is the time and this is the velocity, and this is the angle is theta equals to 30 degrees. We don't know about the velocity and we don't know about the time, even though we can able to find out the acceleration, because A equals to slope of VT graph. Slope of VT graph. So A equals to tan 30 is 1 by root 3 meter per second square. 1 by root 3 meter per second square. Not only this one, here we can go through the one more graph. Same here, velocity time graph only we are taking. Time is on x-axis, velocity is on y-axis. This is the parabola. Inclination or this is opening up of that parabola also we can say. In this case acceleration is positive. Look here, when we are drawing the slope here, this is theta 1 and another point at B. Here the slope is theta 2. In this case theta 2 is greater than theta 1. So acceleration A2 is greater than A1. One more graph we are taking here. See, this is the time and this is the velocity, and this is also parabola, but this is like this is opening and this is down of that curve. Means here slope we should draw here, tangent, and this is theta 1 at A and this is the at B. Here the slope is theta 2. But when you can go through the comparison, theta 1 is greater than theta 2. So A1 is greater than A2. Here acceleration is decreasing. Here acceleration is increasing. So you can take this is the negative and this is the positive. Few problems on velocity time graph. First graph you look here. They have given time is on x-axis, velocity on y-axis. This is in seconds and this is in meters per second. From this graph, find the maximum acceleration. Look here how to find out the acceleration here. Slope of the graph is giving the acceleration. From O to A, this is the velocity and here the acceleration is increasing. From A to B, this is parallel to time and here no change in velocity means A to B acceleration equals to 0. Then B to C, what happens? Velocity is increases, so acceleration is there. From C to D, C to D, here acceleration is coming back and here velocity is increasing in reverse direction. In this case, how to find out the maximum acceleration? Just we can focus on the slope of the graph. First we can take here theta 1. So OA, here we can take A1 equals to tan theta 1. Opposite by adjacent 20 by 20. You are getting 1 meter per second square. Suppose here anyway acceleration is 0. Then B to C, we can take one line here. Slope of this graph is how much? We can take this is the A2. Tan theta 2 equals to 60 minus 20 is 40. And here adjacent is 10 meters per 10 seconds. So here acceleration is 4 meter per second square. Then A3. This is the A3. Here slope of the graph tan theta 3 we are taking. Opposite is how much? 60. This adjacent is we are taking, suppose this is 60. 70 minus 60 is the 10. Here acceleration is 46 meter per second square. So here acceleration is 1 meter per second square. Here acceleration is 4 meter per second square. And here acceleration is 6 meter per second square. So A maximum equals to 6 meters per second square. So only with the help of the slope of this one, theta 1 is how much? 1 meter per second square. Slope of this from B to C, how much it is? Theta 2. So opposite is the 40 by, then adjacent is the 60 minus 40, we are taking here 20. Then here acceleration is 3 meter per second square. Then when you can go for here, you consider this slope is the theta 3, tan theta 3 equals to, opposite is how much? 60. This adjacent is 70 minus 60 is how much? We are taking 10. Here acceleration is 6 meter per second square. Like that we can find out the acceleration with the help of the slope of the graph. Then come to one more graph. They have given here displacement is on y-axis, time is on x-axis. This is in meters and this is in seconds. From this graph we have to draw the velocity time graph. So I am taking here, this is the velocity on y-axis and time is on x-axis. Now you can observe O to A. Velocity is constant. So we can draw here velocity constant means velocity does not change with respect to time. Then when you are going through the A, B, C, here it is parallel to time and displacement is not changing with respect to time means the body is at rest. And here velocity is 0. Till t1 seconds, t2 seconds, t3 seconds, t1, t2, t3, velocity is 0. Then what happens here? That slope is negative. Here theta is greater than 90 degrees. Then once again that velocity is, we can show here that velocity, this is the velocity. We can get like this, negative, and this is the positive. So from this we can draw the displacement time graph, also we can draw the velocity time graph. And one more graph is here. This graph also, they have given the time on x-axis, velocity is on y-axis. In this case, find the displacement and distance. Find the displacement and distance. How to find out the distance? First we can go through the distance. See, area under, we can take this part is 1, this part is 2, and this part is 3, this part is 4, and this is the 5, and this is the 6, and this is the 7, this is the 8. So we are splitting that one based on the geometrical shape. Easy way how to find out the entire area under displacement time is giving the velocity, time is giving the distance. Look here. Here D equals to area of first part. Here base is area of rectangle is what? Length into breadth. So 1 into 2. 2 plus area of first part. And area of second part is how much? 2 minus 1. 1. 1 into 2. Once again you are getting 2 plus. Then area of third. This is the triangle. Triangle half into base into height. Base is how much? 3 minus 2. 1. But height is 6 minus 2. 4. This is 2 plus. Then area of fourth part. Once again rectangle. 3 minus 2. 1. 1 into 2. 2. Then fifth part. Once again you are getting triangle half into base is 1. Then height is 6. This is the 3. Plus sixth part. 8 minus 6. 2. 2 into this is also 4. 2 into 4 8. Then seventh part. Once again you are getting triangle half into base is the 1. And here height is, we are taking in reverse direction. We are taking that height nothing but velocity. We are taking 6 only here. Half into base into 6. Then seventh part. 6 minus 5 is the 1. Then height is the 6. So add all these. 2 plus 2 4. 4 plus 2 6. 6 plus 2 is the 8. 8 plus 3 is the 11. This is the 19. 19 plus 3 is the 22. 22 plus 6 is the 28 meters. This is the distance. Then how to find out the displacement? Here displacement equals to, we are taking here S. When we are going through the displacement, you know that displacement is a vector quantity. It has both magnitude and direction. So entire area above the time axis minus area below the time axis. Here area about this one means up to 6th. But last 2 is we are taking the negative. See, we are taking 4 plus 2 6. 6 plus 2 8. 8 plus 3 11. 11 plus 8 19. And these two we are taking minus 3 minus 6. Finally answer is 10 meters. So finally you should remember that any multiplication, suppose displacement equals to velocity into time. Area under velocity time is giving the displacement. Suppose ratio is a velocity equals to displacement by time. Ratio belongs to slope of the graph. Slope of that particular graph is representing the ratio of that one. So in future also any parameters we are taking, area belongs to integration of that system. Nothing but it belongs to multiplication also, we can say that. Slope is nothing but opposite side by adjacent side, means it represents the ratio. So from this graph we find it the what is the maximum acceleration. They have given displacement time, but we have drawn here velocity time graph, and in this case they are giving velocity time. From this, based on the area, we can able to find out the average distance, and another one is the displacement. Thank you everyone.